Okay, let's see another example of an exponential distribution question. Okay, plane crashes occur at an average of 2.5 plane crashes per year. If there have not been any crashes for the first 9 months of the year, what is the probability there will not be any crashes at all this year? Okay, so here, let me just do some work here. I want to understand the idea. I want 2.5 events per year. What I'm going to do is instead of talk about per annual, I'm going to change it to per month. So I can do 2.5 divided by 12 would give me the number of events per month. Okay, so here I'm just going to do it per month just because it's going to be easier, because here I'm talking about crashes per month. So that's why I want to parameterize here the rate of success. Here I know that 2.5 divided by 12 is events per month, and because I've got successes or counts per time, then I know that this is lambda. Okay, so anytime you've got successes per time, you're talking about lambda. I can take the inverse of this, 12 divided by 2.5 instead of 2.5 divided by 12, and I'll get time per event, per count. When I have area or time per event, that's when I'm talking about beta. Okay, so here is lambda, it's events per time. Here is beta, it's time per event. So 12 divided by 2.5 gets me 4.8. So I can expect 4.8 months to go by for every single event. So once an event happens, I would expect 4.8 months to go by before the next event, the next crash will happen. So this question then is saying, it's asking, given I didn't have any crashes in the first 9 months. So here, let x be the amount of time in months until a crash. We know that z then will be exponential. The rate will be beta, will be 4.8 months per event. Okay, so here the statement's a little bit complicated. It's saying that if there's not been any crashes in the first 9 months, so given the amount of time is larger than 9 months, what is the probability that there will not be any crashes in a year? So what's the probability that z, the amount of time until the next crash, is longer than 12 months, given that it was already longer than 9 months? Okay, so we can do this conditional probability pretty easily with the exponential because of the memoryless property, which I just showed earlier. Okay, so it's just above here. Here's the memoryless property. I've displayed it in class. What really you can end up doing when things are exponential, and only when they're exponential, is you can just take the 2 months and subtract them. I can do 9 months, 12 months, subtract 9 months. Here, the probability of this condition simplifies to the probability of just not having a crash for at least 3 months. Okay, so that's pretty easy. Using your formula, you can get that just by plugging in, this is e to the power here, I want 3 is the power, divided by beta, which is 4.8. Okay, the way that you would do this in Minitab would be to go to Calc, Probability Distribution, Exponential. I want a cumulative probability. I said the rate was 4.8 months per event. I want to find the cumulative probability of 3. So here, probability of x being less than or equal to 3 months is 4.6, so forth. I don't want less than 3 months. I wanted more than 3 months. So if I simply just do 1 subtract this value, I will, of course, get this value.